Okay, so for today's lecture, we will discuss another important topic in strength of materials, which is about strain. Okay, so what is strain? Well, in basic terms, strain is the deformation that is experienced by a body when it is subjected to a force. Okay, so say for example, you have this bar length L. Okay? And then you pull this bar with the force F going to the right. So what will happen is uh, later on, mo taas na siya. Okay? Elongate. Okay, mo elongate na siya. So the deformation or the delta, if we divide it by the total length, okay, so that is what you call strain. Okay, or strain in other words is just the percent deformation that is experienced by the body as it is being stretched by this force F. Okay, so we will talk about uh, axial strain and also the shearing deformations, axial and shearing deformations. Okay, so this is the basic idea of strain. Okay, since this is in unit of length divided by unit of length, this is dimensionless. Okay, but usually ang unit ano niya is can be pwede meter per meter or inch per inch, no? Para masabtan nga strain din na siya. Okay, so let's discuss some basic properties of a material. Okay, so in order to understand this stress strain diagram, imagine that you have a steel or a material and then you subject it to a tension test. So in a tension test, the specimen is clamped between the jaws of the machine and you subject a force and also determine the specified deformation, okay, in order to get this stress and strain diagram. Okay, so when you apply a now this is typically for a steel material. So when you apply a load or a force in a tensile test in a steel, the deformation and the force that is being applied is the relationship between the two is linear or proportional. Okay, meaning as you increase the force, the elongation also increases in a linear fashion until such time that it reaches this proportional limit. Okay, so sa proportional limit, below the proportional limit, if you apply a force to a material, it will go back to its original shape. Okay? No? So, mo na siya significance ani. diri nga part proportional limit nimo. Okay? So beyond the proportional limit, uh, okay, so usually ang mga structures is designed to operate diri within this proportional limit. Why is that? Because so that your structure will not fail. As I have mentioned earlier, when you apply a force into the material, it goes back to its original shape. So, meaning, kaya ra kay sa imong material ang imong gi-apply nga load. Okay, so, if you increase the force, the relationship will now reach to the elastic limit. Okay? So, ang relationship ana niya dili na linear. Sa elastic limit, the material will not return to its original shape. There is now a permanent deformation. Okay? There is now a permanent deformation. Although, gamay pa na siya. Again, if you increase pa gid nimo ang force or ang load in the tensile test, it will reach the yield point. This one. The yield point, this is the point at which there is an appreciable elongation. No? So, nanay dako nga elongation na ma-experience imong material. Appreciable na siya. Okay, so the material is now at the yield point. So there is now an appreciable deformation. And then you continue to increase the load. So the material will again deform. Medyo dako na po ang iyang pag-deform until such time that it will reach this ultimate strength. Okay? So the ultimate strength, it is the point wherein this is the maximum stress or maximum force that the material can handle, and then beyond this one, the material will now eventually break or fail. Okay, so that is how a material behaves. Okay, of course, this is for elastic material, mga steel. Okay, so it is worth mentioning that when you design your material, your structure, do not aim for this ultimate strength. No, dili na mo siya nga isagad gid nimo dire. As an engineer, dapat diri ra ka mag-work diri within the proportional limit para you have confidence that your structures will not fail. Okay? Okay. Again, this is the formula for strain. This is the symbol for strain. Sigma over L. Okay, take note. These are the conditions in order to apply this equation. The specimen must be of constant cross-section, the material must be homogeneous, and the load must be axial. That is produce uniform stress. Okay? Okay, so let's proceed with the working stress and factor of safety. Okay? The working stress or the allowable stress is the maximum safe stress a material may carry. So in designing, the working stress should be limited to values not exceeding the proportional limit. Okay, as I have said, work only in the proportional limit. Okay? However, since the proportional limit is difficult to determine accurately, it is customary to base the working stress on either the yield point or the ultimate strength divided by a suitable number. Okay, so kaning number nga n is the factor of safety. Okay, so unsa may importance ni factor of safety, meaning if you have a factor of safety of 2, meaning based on the yield point, you're confident that your structure can actually carry twice of the working stress, meaning for example for bridge, no, usually ginabutangan man na og 5 tons, 20 tons capacity, but in reality that was napanay factor of safety, no. So kung yun ka og ang kanang nga bridge na ana siya factor of safety of 2, kunya 5 tons iyang capacity nga gibutang dito, actually it can carry 10 tons, no. So nana na siya. Okay, the yield point is selected as the basis for determining the working stress in structural steel. Okay, so let's proceed with the Hooke's law, and we will discuss the axial deformation and shearing deformation. So, actually si Robert Hooke ang postulated that stress and strain is proportional, no, within the katong proportional limit. Dito ra po sa proportional limit katong linear ang iyang behavior, no, kwanto siya ma-describe using this equation. E is equal to stress over strain. Okay, so kaning E is the modulus of elasticity. Okay, sometimes it is called the Young's modulus, no? So ang value aning E or the Young's modulus or modulus of elasticity, tawagon na nato ning modulus of elasticity. Ang value ani niya is the same sa stress because ang imong strain is dimensionless man, no? So usually for steel, yung modulus of elasticity is 200 times 10 to the 9 Newton per meter square or 200 gigapascal. Okay, a convenient variation of Hooke's law is obtained by replacing stress by its equivalent value, P over A, and the strain by del over L. Okay? Therefore, ang imong strain, no, okay, so let's proceed with shearing deformations caused by shearing forces. Okay, so for shearing forces, so what happens is that the element that is subject to shear does not change its length, but what changes is its shape. Okay, so for example, if you have this rectangular cross-section, if you apply a shearing force in this direction, it will now become somewhat like a parallelogram. Okay, so in order to determine the shearing deformation is accounted by this angle gamma. Okay, so gamma from this figure is just the tangent inverse of this shearing deformation over length, this one. Okay, so tan gamma is just del S over L. But for since the angle gamma is usually very small, no, meron ka na, tangent gamma is approximately equal to gamma. Therefore, the deformation is just shearing deformation over L. Okay, so the relation between shearing stress and shearing strain, assuming Hooke's law applied to shear is, okay, diba? This is the shearing stress. Shearing stress is just equal to G over shearing strain. Okay, shearing strain. Where the G is the modulus of rigidity. Okay, so this is just familiar, more almost the same ang ilang form sa atong Hooke's law. Stress is just equal to modulus of elasticity times strain. Okay? And if the relation between the shearing deformation and applied shearing force is then, no, kung mangitatag counterpart ani nga equation for shearing strain, it would be this one. Del S is just VL over AG, where the V is the shearing force, and A sub S is shearing area. Okay, so let's have this example. Compute the total elongation caused by an axial load of 100 kilonewton applied to a flat bar 20 millimeters thick, tapering from 120 to 40 millimeter in a length of 10 meters. The modulus of elasticity is 200 gigapascal. Okay, so based from this figure, this is top view. Top view ni siya, no? We cannot apply, whereas for the elongation, del, cannot directly apply the PL over AE because this is not constant cross-section, di ba? As what we have discussed, ang mga assumptions ato is apply to nimo for constant cross-section. Okay, so what we will do is we will get a small strip here. No, kung magkuha kag small strip diri, murag ma-approximate nimo nga rectangular siya, no? Mura na sa constant cross section. Ang length niya is dx. And then ato rin ang i-sum up all, no? All strips from 0 to 10. And you can get the total elongation. Okay? Okay, so we have this plate. Okay, so this is the top view. This is thickness is 20 millimeters. And the length of this side is 120 millimeters. This one is 40. We are asked to find the total elongation. Okay. Again, we cannot directly apply this equation because the constant yung cross section. So what we will do is we get a small strip with a length dx. Ang distance niya is x, and then distance niya is y. Okay? Okay. So, since this is a infinitesimal length, so this one also is infinitesimal ato makuha, and then ato na lang din yung i-sum up from 0 to 10. Okay, the force is 100 times 10 to the 3 Newton. The length is, okay, the unit is Newton. Length 10 meters. Okay, let's get the area. Ang area ani, no? Kung small kay ni siya, dili na siya mag-taper, mura na siya rectangle karon. So dx, pangitaw na to ang length ani. Unsa ang h sa lang to butang length ana. Okay, so unsa ang length ana? Okay, we can get, since ang length po dani kay vary man ni, depende sa length niya or distance niya. So ang atong buhaton na is Okay? So kung 20 ni, okay, so this one is 60, this one is 20. And then, we will y mo ni siya. Y. So by ratio, we will get y. Okay, y man ni. Y. By ratio and proportion. Kani nga length kani nga length gikan diri padung diha. This is y minus 20. Yang length ani niya kay x man ni. Length sa overall is 10. So we can get y by kani similar triangles or ratio and proportion. So y minus 20 kani nga length over x is just equal to unsa man ni? Unsa ni yung length ani? This is y minus 60. Tama? No, not y minus 60. 60 minus 20. Or this is equal to 40. O 40 ni dire kay 20 man ni. So 40 or at na lang ibutang 60 minus 20 is to 10. Therefore, y is no yan eh. 4x plus 20. The unit is millimeters. Okay? So makuha na nato ang area. Ang area di ay ani kay wide ko naman eh. H dx. H man eh. H na kani y man eh. So ang h nimo is just 2y. So mahimo na ning 2y dx. Okay, that is the area. I'll now erase this one. Okay. The area is 2y dx. But what is y? Unsa itong y? Y is equal to 4x plus 20. The unit is millimeters. Okay, so pag times na to ani 4x plus 20 dx sa unit. Unit ani niya is mm squared. The area is 8x plus 40 dx. Tama? No. No. Area. No. Dili ka ng area. Dili ka ng area. Dili dahil dx. Length man eh. Okay, wrong. Ang area ni is top view man eh. Top view. So, ang area ni is ana ni siya. Ano? Ana. Kung mo ni ang 2y ani 20 mm. So, kuan din eh. Area is 2y times 20. Tama. Okay? Okay. So, 2 times 4x plus 20 times 20 ay morning 160x plus 800. Unit is mm squared. Okay. Mahimo na rin 160x plus 800 mm squared. Ang ini mo is 200 times 10 to the 9 Newton per m squared. Okay? PL. No, dili 10. Ang length ani, ang sa may length ani. Ang length ani niya is kaning dx. Tama? Mo ni length ani niya. Okay, tensile man eh. Tensile. Tensile man eh. Gaana man eh actually. Gaana man eh. Taper. No? Gibira siya. So, mo ni yung length dx. Mahimo ning na 100 times 10 to the 3 dx. Okay. Times 10 to the 9. So, kung i-convert na to ning mm squared, kung na yung reason. Kung i-convert na to ning mm squared, diba? 1m, 1,000 mm squared. So, mahimo ning 1 times 10 to the negative 6. Ano eh? So, makancel na rin diri. Ang mabili na ni diode is 0.5 dx over 160x plus 800. Okay, yung unit na mabilin ani is meter. Meter, no? Okay, so ato ning integrate from 0 to 10. Okay, so ang problema na lang ni man is saan ni pag-evaluate. So, recall po ni mo ito imong mathematics, no? Klaro ba? Okay. So sa math ani, meaning let you 160x plus 800. So du is 160 dx. Okay, or du over 160 is, okay, so may mo rin yung 0.5 over 160 ln of u, but u is 160x plus 800 divided from 0 to 10. Okay? So, ano na siya? Of course, di na ito na ipakita. Substitute naman na largo. There is 3.44 times 10 to the negative 3 meter, or 3.44 mm. Okay? So, pag binat ni mo nga plate, muna yung force ni mo 100 kilonewton, morning elongation niya 3.44 meters. Gamay ra kaya na actually 3.44. So that's it. So you have about determining strain of a material, and specifically we'll be discussing about the Poisson's ratio. Okay, so what is this all about? Imagine that you have this metal bar, okay, the one in black. Now, if you subject this one to a tensile stress along the x direction, so this is the x direction, this is the y direction. So what happens is that as you try to extend this bar, so what happens is there will be deformation along the x, so mo taas ning bar nimo. But Also, mo ma-observe ni mo nga mo gamay sad ang iyaang length according in the direction sa y and z axis, no? So kung birahon nimo mo gamay ang iyaang length with respect to y axis and also with respect to z. So kung observe niyo when you play ka ng rubber band, no? Kung inato nimo ng rubber band sa metabo, mo elongate ang iyang length, mataas. But ma-observe nimo nga mo kagamay ang iyaang diameter, no? Kay mura man na siya og lingin. Kung binato na nimo until sa time nga maputol siya. Okay? So the question is, how much is the deformation in the y direction or in the z direction with respect kaning sa load nimo nga i-apply sa x direction? So in order to get that one, we need to get this Poisson's ratio. So this ratio states that the strain in the y is divided by the strain in the x is also equal to the strain experienced in the z direction with respect to x. So divided by strain in the x direction. So kaning negative nga sign, nag-denotes ni siya nga pagamay ang imoang decrease ang length sa imoang material. Okay? So, usually, no, for most steel, ang value sa V or the Poisson's ratio lies within 0.25 to 0.3 and 0.2 for concrete. Okay? So, this is for, nagalini siya for isa ka force nga gi-apply nimo sa x direction. How about if you apply a force in the x direction and also in the y direction? So duha na ka force, no? So this is what you call the biaxial deformation. Okay. So in order to get the total strain, okay, birato na nimo sa x, may elongate na siya na sa strain, sa y, na po na sa strain nga ma-produce. Pero agatong pagbinat po nimo sa y direction, maka-affect po to sa x nimo. So how do you get the total strain in the x direction? So kani, you use this formula. Strain in the x direction is just equal to the stress over E minus Poisson's ratio times the stress in the y direction over E. Okay, if you want to get the stress in the x direction, imura ni siyang i-transpose, no? Para maabot ka ng equation. And also for the y direction. Okay, so familiarize lang ninyo ni nga equation, no? Makita ninyo nga this is the kung simple lang na stress, no? Kanira, strain, simple nga strain kanira. Sigma y over E. But since naman kay force pod sa x nimo, so mo gamay siya mo nang minus v sigma x over E. Okay, this is for two forces, no? How about kung three forces or three stresses yung gi-apply sa material? So naa kay force along x, y, and z. So in order to get the total strain in the x direction, so gamito nimo ni, no? 1 over E times sigma x minus, so minus ano mo sa strain sa y times the Poisson's ratio minus sa z. So dali ra sa timan, ano? mura ra sad kaning dire sa two-dimensional, then mag-add na lang ka og V sigma Z over E na pod. So, mura man ni siya. Okay? Now, tensile stresses and elongation are taken as positive, compressive stresses and contraction are taken as negative. So, if we want to get the relationship between modulus of elasticity, modulus of rigidity, and the Poisson's ratio, you use this equation. So, timanan ninyo yung equation kay what if dili given ang Poisson's ratio but given ka ng E and G? Nakuha mo siya using this equation. Okay, so let's have an example. Example 223, a rectangular block. Steel block is 3 inches in the X. So, ang X na to, X, Y, Z. So, 3 daw. So, muna siya. 3 inches. 2 inches in the Y. So, asa ang Y dire. So, 2 inches kani. And 4 inches in the Z direction. The block is subjected to a triaxial loading of 3 uniformly distributed forces, 48 kips in the X, 60 kips in the Y, and 54 kips in the Z direction. Now, kaning kips is kilo-pound. So, kung ano na siya, short for kilo-pound. So, meaning, 1,000 pound is so, kung ano siya, 54,000 pound of force. If V is equal to 0.3 and elasticity is 29 e to the 6 psi, determine the single uniformly distributed load in the X direction that would produce the same deformation in the Y direction as the original loading. Okay, so let's draw the diagram. So we have this block. Now it is subjected to a triaxial loading. So you have 48 kips in the X direction, 60 kips compression. So paano siya, no? In the Y direction, and 54 kips along the Z tension. Okay, so what is asked in the problem is we are asked to find if we are to reduce this loading into a single loading, no, along the X, pila daw ning a force that would produce the same strain in the Y direction as compared diare. Okay? No, so naman kay makuha nga strain dire along the Y. So question niya, what if is reduce nimo ni siya into single loading along the X nga same ra gyapon og strain sa Y, pila daw ning P of X. Okay, so in order to get that one, we need first to determine the strain dire, no, para using this one, paano na to ang Poisson's ratio, ani, we will get the strain or the force along the X direction. Actually, wata kabalo no whether tensile ba ni or compression ba ni siya. So for this example, ito lang assume nga tensile, but later on, we makita nato na siya, depende sa strain, direction sa strain dire, may bawa na to ang direction ani. Okay? Okay, so the equation, no, for triaxial loading, so ganito, strain in the Y direction is just 1 over E times sigma X minus V times sigma Y plus sigma Z. Okay? Tama? So we need, given man eh. So we need first to get the stresses along the X, Y, and Z direction. Okay, so what is the stress in the X direction? This is just force over area. So force, 48 kips over area. Unsang area ni? Kaning area. Right. So this is 2 times 4. So 8 square inches. So this is 6 KSI tension. No? So i-indicate po din yung whether tension or compression. Sigma Y, this is 60 kips over ansang area ni. Yan ni perpendicular sa iya kani. So that is 3 times 4, 12. 3 times 4 or 12. So this is 5 PSI compression. And then sigma Z 54 area is 2 times 3, 6. Tama? So this is 9 PSI tension. Okay? And then we substitute that there. Given maning modulus of elasticity which is 29 times 10 to the 6 PSI. Take note, no? PSI. So, kani PSI. So, ito running times of 1,000. So, mahimo na ning sigma x is no, dili ni sigma x. Y mans. Sigma y. Sigma y. Tama. Okay. Tama. Okay, so sigma y ni. Now, stress in the y minus. So, in the y, again, di ba? Compression is, we take that as a negative. So, negative 5,000. Negative 5,000 minus 0.3 times sigma x, 6,000. Again, nahimo ning 1,000 kaya again ning pound PSI, kaning PSI. This is equal to 5,000 PSI. Okay, plus 9,000. Okay? Therefore, the strain in the y direction is negative 3.276 times 10 to the negative 4. Sa unit ani. Unit ani is wala. Diba? Kay strain man eh. Okay? So, naa na tayo strain. So, na i-relate dire. So, mo ni siya ang okay, so the value is negative, meaning ni gamay. Ni gamay, no? Ni gamay din eh. Moana din ni siya karon. Moana ni siya. Sama na. Pag binat ni mo, gamay ni. Hindi na lang na to. Kaya may elongate man na sa may elongate. May mo na lang din yung mana. Din eh. Taas. Pero gamay. Okay? Taas pa ng gamay. So, meaning, sakto running attention din eh. P of x is tension. Diba? Kasamaan mo gamay ang sa y kung yung inaton. No? So, i-relate na to na ikaroon ng strain. Take note that stress sa y is just equal to E ana. No? Ako na ning irisan. Klaro. stress sa y is just E times strain. Okay. But, according to the Poisson's ratio, V is negative EY over strain sa X. Tama ba? Strain sa X. Okay. Dili ka na itong gamiton. Ani di itong gamiton kay para mawala ni. Okay. Okay. So, mahimo na ni karong negative EY, strain sa Y, V, stress of X over E. Okay, but take note nga, kaning stress is force over area. So, ang force karon is just A, E negative over V. So, unsa ang area? Ang area is kani diri. Diba? That is negative 8 in square. Ang E mo is 29. Tama? 29 times 10 to the 6 PSI. Strain mo is negative 3.276 times 10 to the negative 4 over 0.3. Therefore, the force along the X is 253.33 kips tension. Okay? That's it. Muna ang force nga makaproduce of negative 3.276 times 10 to the negative 4 strain in the Y direction.